133, equations of parallel and perpendicular lines. Before we get into that, let's review our corresponding 2.0 target, as it will be very helpful for us as we go through and learn this new 3.0 target. So it says, how can you tell if two equations are parallel? So remember, parallel lines have the same slope. They also never intersect. How can you tell if two equations are perpendicular? Remember, they have the negative reciprocal slope, and they intersect at a 90-degree angle. So those are two key pieces. This question here, this is basically our 1.2.3 question. It says a line is parallel to the linear function y equals 4x plus 12 and runs through the point 218. What is the linear function? So whenever you see what is a linear function, always think slope-intercept form, y equals mx plus b. So that should be our starting point. So for us to write an equation in slope-intercept form, we need m and b. So we're told our line is parallel to y equals 4x plus 12. So if it's parallel, it means it has the same slope. The slope of this line is 4, since 4 is with x. So our line would also have a slope of 4. In addition, we need to figure out our b value, and we can use this point to do so. So at this point, we have y equals 4x plus b. We don't have b yet, but this point is an x and y value on our line, a solution to our linear function. So we can plug in 2 for x and 18 for y, keeping 4 for m. And now we have an equation where we can solve for b. So when we're solving for b here, 4 times 2 is 8. Subtract 8 from both sides, we get b equals 10. So m is 4, b is 10, so we plug those into slope-intercept form to get y equals 4x plus 10. And there we have it, a parallel line that goes through that point. So as we move into our 3.0 target here, you'll notice quite a few similarities. So let's read through our first question together. It says a line segment is given below, right here. Find the linear function which is parallel to the given line segment and also runs through the point 1, 3. Okay, so I graphed that point. You don't have to. So when we are solving this problem, again, it says find a linear function. So again, we should think slope-intercept form. The way that we go about this is the same as really the previous problem. In the last problem, what we did was we found the slope first, and then we found the y-intercept. Here we're going to do the same thing, except instead of being given a function, we're given its graph. We're given a segment. So we want to find the slope. So in the previous problem, we were told our line is parallel to y equals 4x plus 12, so we used that 4 to get our slope. In this one, we're told our line is parallel to this segment. So again, it means it has to have the same slope. We just have to figure out what's the slope of this line segment. Well, from A to B, we go up 1, 2, 3, 4, over 1, 2. So our slope, or our m, for this segment would be 4 over 2, which would be 2. Since our line is parallel, that means our slope also has to be 2. In addition, we're told our line goes through the point 1, 3. So, as is, we have y equals 2x plus b, so 2 for m. And again, we can plug in 1 and 3 for x and y like we did in the previous problem. So plug in 1 for x, plug in 3 for y, and now we have an equation where we can solve for b. So 2 times 1 is 2. Subtract 2 from both sides, and we get b equals 1. So we have 1 for b, 2 for m, so our line would be y equals 2x plus 1. So notice the similarities. In the 2.0, we find the slope from the given equation. In the 3.0, we find the slope from the given line segment. So slightly different, but a lot of similar ideas. You'll recall from our 2.0 target that we worked with both parallel and perpendicular lines. You'll see that here as well. So here we have a line segment, again, is given below. Find the linear function which is perpendicular to the given line segment and goes through the coordinate 2, 0. So again, what we'll do is we're going to find the slope, our m. We're going to find that y-intercept, our b. And then we're going to write that function. So to find the slope, we need to first figure out what's the slope of this segment. So we go from left to right, we go down 1, 2, so 2 there, over 1, 2, 3, 4, 5. So the slope of this one would be negative 2 over 5. So remember, it has to be negative since it's going down into the right. So our slope, which is perpendicular, will be the negative reciprocal of negative 2/5. So change the sign, so negative to positive, flip the fraction. So 2 over 5 becomes positive 5 over 2. So when we're thinking slope-intercept form, we've got y equals 5 over 2x plus b. Again, we're given a coordinate, we're given a point, so we plug in that point for x and y. So 2 for x and 0 for y. Remember multiplying fractions? So this is the same as 2 over 1. You just multiply straight across. 5 times 2 is 10. 2 times 1 is 2. 10 divided by 2, well, that's 5. Subtract 5 from both sides, and we get b equals negative 5. So we have our m is 5 over 2. Our b is negative 5, so we plug that into y equals m x plus b plus negative 5 or minus 5. So same process. Figure out what the slope is, so you need to find the slope of this segment. Once you find the slope, you can use that to determine the slope of your function. Since it's perpendicular, we took the negative reciprocal. So change the sign, flip the fraction, then we plug in the slope, plug in the point into slope-intercept form to figure out b. Lastly, you just plug in m, plug in b into slope-intercept form, and you've got your function, your equation. Okay. All right, let's put it all together. So here, what I'd like you to do is, let's start in the middle here. So it says, what is the slope? So determine the slope of this segment. Then over here, I want you to write a line that is parallel to this segment and runs through this point. Over here, write a line that is perpendicular to this segment and runs through the point. So you're using this segment for both problems on the left and right. So start with determining the slope, then move to those two problems. Pause the video, please give it a try on your own, and then we'll come back and make sure we got this down. Okay, we're back. The slope here. So here to here, we go up 1, 2, over 1, 2, 3, 4, 5, 6. So our slope is 2 over 6, which we can simplify. Divide both the top and bottom by 2, and we get 1 over 3. Notice here, I am looking to see the scale. I'm making sure it's going up and over by 1s. So if it weren't, you'd make sure to check that for your slope. Okay, so over on the left, it says write a line that's parallel to the given line. It's actually a segment, sorry about that typo, and runs through the point negative 6, 12. So we want a line that is parallel. So parallel means same slope. So our slope also has to be 1/3. So let's plug that into slope-intercept form now. And it has to go through the point negative 6, 12. So we plug in x and negative 6 and 12 for x and y. So negative 6 for x, 12 for y, and we solve for b. 1/3 times negative 6 over 1 would be negative 6 over 3. Negative 6 divided by 3 is negative 2. Add 2 to both sides, we get b equals 14. So our line then, we have m is 1/3, b is 14, so we have y equals 1/3 x plus 14. So that'll go through our point and have the same slope, be parallel. For the next one, it says a function runs through the point negative 5, 10 and is perpendicular to the line segment to the left. What is the linear function? So it's perpendicular, so that means our slope must be the negative reciprocal of this one. So this slope has positive 1/3, so our slope will be change the sign negative, flip the fraction to 3/1. Or that's the same as just -3. So let's plug that in to slope-intercept form now. Solve for b by plugging in our point for x and y. So -5 for x, 10 for y. -3 times -5 is 15. Subtract 15 from both sides, we get -5 equals b. So m is -3, b is -5. So y equals m x plus b, which will be -5. And there we have our function. Okay. So when you are writing parallel and perpendicular functions here, your steps are to find the slope. So look at the line segment, figure out what its slope is, then plug in the slope and point to figure out b. Once you have m and b, then you can write your function. Same idea for both, just make sure to check whether it's parallel or perpendicular. Parallel means same slope, perpendicular means negative reciprocal.